Probability concepts. The probability Probability concepts. The probability of any event has to be between 0 and 1. The sum of the probabilities of mutually exclusive and exhaustive events must be equal to 1. So if we say that we have three possible events, the event that the stock price goes up, the event that the stock price goes down, and the event that the stock price remains the same. These three are mutually exclusive events because they cannot happen at the same time. And these three together are exhaustive because they represent all that can possibly happen with a stock. There are three methods of estimating probabilities. Empirical probability is based on analyzing the frequency of an event's occurrence in the past. A priori probability is based on formal reasoning and inspection rather than personal judgment, and subjective probability is an informed guess based on personal judgment. The odds for an event can be calculated based on probabilities. So the odds for a given event can be calculated as the probability of the event divided by the probability of the event not happening. And then the odds against an event equals the probability of the event not happening divided by the probability of the event. An unconditional probability is the probability of an event occurring irrespective of the occurrence of any other event. It is denoted as the probability of a particular event. So we can say, what is the probability that the stock price will go up? That is an unconditional probability. A conditional probability is the probability of an event occurring given that another event has occurred. It is denoted like this. So probability of A given B. If we say what is the probability that the stock price will go up given that the economy improves, this is a conditional probability. The multiplication rule gives the joint probability of two events. The joint probability is the probability of two events both occurring. So if you have event A and B, then the joint probability of A and B both happening is given by the probability of A given B. This is a conditional probability multiplied by the probability of B, which is the unconditional probability of event B happening. Let's take a very simple example. Say the probability that the economy will improve is equal to 0.6 and the probability that the stock price will increase given that the economy will improve is 0.4. What's the probability that the stock price will increase and economy will improve? So this is a classic application of the multiplication rule. We simply multiply these two numbers and we get 0.24. Notice that based on this formula you can derive other formulas. So if you are given the joint probability and the probability of B, then you can come up with the probability of A given B. The addition rule gives the probability that at least one of the events will occur. So the probability that A occurs or B occurs is equal to the probability of A plus the probability of B minus the joint probability of A and B both occurring. Again, let's take a very simple example. Say the probability that stock A increases is 0.4. The probability that stock B increases is 0.5. The probability that both A and B increase is 0.2. Then the addition rule tells us that the probability of at least one of the two stocks increasing is equal to 0.4 plus 0.5 minus 0.2, which is 0.7. When answering questions, students sometimes get confused about whether to use the multiplication rule or the addition rule. So here is my advice. Just write down both the rules and then use the numbers or the information given in the question. Let's say you are being asked to calculate the joint probability. Notice that can be calculated using both formulas, but the question is what information is provided. If the question is giving you the probability of A given B and the probability of B, then you use this formula. On the other hand, if you are given the probability of A or B and you are given this probability and this probability, then you clearly use the addition rule. Next we come to the total probability rule. This is used to calculate the unconditional probability of an event given conditional probabilities. Now here is the rather complicated looking formula, but it is actually fairly straightforward, and this example illustrates how to use the total probability rule. We are given several probabilities here. So there is the probability of B1, B2, B3. These are three different events. And then we are given some conditional probabilities. Using this information, we want to come up with the unconditional probability that the stock price will rise. Now, with this information and this question, we should apply the total probability rule, which has been done over here, and our answer is 0.67. You need to know the distinction between independent events and dependent events. Two events are independent when the occurrence of one event does not influence the occurrence of the other event. So for example, if one event is that it will rain and the other event is that the stock price will go up, it is fairly safe to say that these two events are independent. So we can say that the probability that it will rain given that the stock price is up is equal to the probability that it will rain. So this conditionality makes no difference. With dependent events, the occurrence of one event does influence the occurrence of the other event. So what we can say is, if the economy improves, that does impact the probability of whether the stock price will go up or not. So stock price rising and above average economic growth, we can say that the probability that the stock price goes up, given that there is above average economic growth, is going to be higher than simply taking the probability that the stock price will rise. So these two events are dependent events. Next, you need to know how to construct a tree diagram, and this is fairly straightforward. I'd encourage you to go through this example, and that will show you how to come up with a tree diagram. Covariance measures how two variables move together. This is the formula. You need to know how to apply it. Typically, you will be given multiple scenarios. Here we've taken two scenarios. There is a probability of each scenario, and then we have the returns of stock A and the returns of stock B under each scenario. Given this information, how do you come up with the covariance? The first thing to do is to come up with the expected return of A and the expected return of B. So the expected return of A is 0.2 into 1% plus 0.8 into 8%. So that's based on this information. Similarly, you come up with the expected return of B. Then the covariance is based on the formula. So the probability into 1 minus 6.6, 6.6 is coming from here, times 3 minus 5.4. So the 3 is coming from here. This is the 0.2 probability event. And then minus 5.4, which is the average from here. And then we do the same thing for the situation where we have a 0.8 probability and come up with this answer. If you spend a little bit of time on this, it will become fairly obvious how to calculate covariance. Correlation is a standardized measure of the linear relationship between two variables. It's the covariance divided by the two standard deviations. The correlation will range between -1 and +1. A correlation of +1 means that two variables move together perfectly. -1 means that they move in opposite directions, and 0 means that there is no correlation or there is no relationship between the variables. With covariance, all we can tell is whether there is a positive or a negative relationship between two variables. The number in of itself doesn't have much significance. And that's why we often convert a covariance number into a correlation number. Correlation is a very useful measure, but it has limitations. Number one, correlation only assesses the strength of a linear relationship. So for example, we might have two variables x and y with a very strong non-linear relationship. When we look at the correlation between x and y, the correlation might be 0 or it might be very low. So the correlation measure doesn't tell us anything about this non-linear relationship. Number two, the correlation coefficient is sensitive to outliers. So if we have x and y and there are some data points that are outliers, that will heavily impact the correlation number that we calculate. Number three, a strong correlation does not imply cause and effect. So we might have variable A and variable B where the correlation is high. This does not necessarily mean that a high value of A results in a high value of B. It is possible that there is another variable C that is highly correlated with A and B. So the fact that A and B are highly correlated is because of a third variable. But the point here to remember is that a strong correlation does not necessarily imply a cause and effect relationship. And the fourth limitation is that correlations may be spurious. This means that we are looking at a particular data set, and just by chance in this particular data set, the correlation between two variables such as A and B is high. If we look at another data set, then it's quite possible that the correlation between A and B is not very high. So when a relationship happens because of chance, then that's called a spurious relationship. Moving on to scatter plots. A scatter plot is a graphical representation of correlation. In this example, we have two variables A and B. Just by looking at the scatter plot, we can see that there is a positive correlation because as A increases, so does B. Over here, we have a negative correlation. So let's say we have variables C and D. As C increases, the value of D decreases. So this is a negative correlation. And over here, there seems to be no relationship between variable X and Y. Therefore, we say that the correlation is 0 or there is no correlation. Expected value of a random variable. In a sense, we've already covered this. The expected value of a given random variable is the value under each situation times the probability of that situation, and this is illustrated over here. Portfolio return and variance. If you have a portfolio of two stocks, the expected return of the portfolio is the weight of the first stock times the expected return of the first stock plus the weight of the second stock times the expected return of the second stock. The variance of the portfolio is calculated using this formula, and again the formula is illustrated over here. This symbol represents the correlation. Next we come to the Bayes formula. This gives us the probability of an event given some new information. Now, many students have issues with this formula. I'll just tell you how to remember this. The idea is that you have the probability of a given event and then new information comes in. How does that new information change the probability? So this is a conditional probability. It's the probability of an event given new information. You can try and remember that your starting point is the probability of the event, and then this needs to be multiplied by a ratio. The ratio is simply probability of I given E. So here we say E given I. In the ratio, you change that to I given E, and then you divide that by the probability of the information. And again, this ratio is multiplied by the original probability of the event. The formula is illustrated in this example. Notice that from the information given, we first have to use the total probability formula to come up with the unconditional probability of the information. So that's this denominator. The probability of the event is given in the data. The probability of the information is what we find over here, and probability of I given E is also provided in the data. So we plug in the numbers and we come up with the probability of the event given the information. Permutations. This is the formula for permutations. With permutations, we select a certain number of items from a larger set where the order does matter. So if we select 4 stocks from 10 stocks where the order matters, so selecting stock 1, 2, 3, 4 is different from selecting stocks 4, 3, 2, 1, then we call this a permutation. The formula is over here. This is illustrated in the example, but if you get a permutations question on the exam, you should use the calculator, and here are the relevant keystrokes on your calculator. And finally, we have combinations. This is the formula. With combinations, the order does not matter. This is an application of the formula, but again, you should use the financial calculator, and here are the keystrokes on your BA2 Plus calculator. That is it for this reading.